Green Lake is fed by a stream having a flow rate of 1.2 meters cubed per second and a phosphorus concentration of 0.045 milligrams per liter. Runoff from adjacent homes adds phosphorus at an average annual rate of 0.26 grams per second, and a river flows from the lake at a flow rate of 1.23 meters cubed per second. What's the trophic state of the lake? Well, if we look at this table, we can classify the trophic state of the lake using phosphorus concentrations. So what we're going to do is we're going to find the steady state phosphorus concentration of this system and find that concentration on the table. So, okay, let's see if I can do it. Okay, so we've got some stream inlet coming into our lake. This stream inlet has a flow rate Q. We have an outlet with that same flow rate. Concentration of phosphorus coming in, we'll just call that CPN. And then we also have an inlet coming in from stormwater runoff. So this is already in a mass flow rate, mass per time. So we're going to call that MPN. And then assuming this lake is well mixed, whatever concentration is in the lake is the concentration coming out of the lake. Okay, so this just becomes fairly straightforward by this point in the term, mass balance. So we have dCpV by dt is equal to CPNQ plus mass of phosphorus in minus CPQ. Okay, and we're looking for the steady state concentration in order to classify this trophic state. So that term goes to 0. Rearrange this. We get Cp is equal to Cpn plus this mass flow rate in from the runoff divided by Q. Okay, so this is 0.045 milligrams per liter plus 0.26 grams per second. Let's turn these grams into milligrams to stay consistent. That'll be 1,000 milligrams per gram. And then we have 1.2 meters cubed per second. And let's turn this meters cubed into liters to stay consistent. But guess what? We have 1,000 liters per meter cubed. So these conversion factors actually cancel in this case. But we get Cp is equal to 0.261 milligrams per liter, which is equal to 261 micrograms per liter. Okay, why micrograms? Because the whole point is I want to look at this table, which is in micrograms per liter. And if I look for 261 micrograms per liter on this table, I'm pretty easily within the eutrophic range. So hence, green lawn is eutrophic. Okay, a couple of things that we could change. We could do the same process but with chlorophyll A concentrations and classify the trophic state that way if we had that sort of information instead of phosphorus. Or we could have some transformations happening in the lake. Those are a couple different ways that we could change this problem or make it a little bit more spicy.